morning children, welcome to the chemistry class. It's very long today I meet you. I hope all are very safe, okay, and at the same time you start study. Okay, so now I enter the topic. Till the last session I complete the VB theory, valence bond theory. Okay, today's session I am taking the topic crystal field theory. Okay, if any theory discussed based on the previous one, based on mean the previous three theory limitations. Okay, so from the limitation of the previous theory arises the next theory. Okay, this is a general one, children. For example, Thomas. Okay, the structure of atom, this concept if you know very well. So first Thomson model, talk about the structure of atom. So in Thomson model has some drawback. So next one Rutherford. So next to Bohr theory, same way. Here in VB theory has some limitations in coordination compound. So what is the limitation? Means first one, it does not explain the color of the coordination compound. And next one, it does not consider the magnetic movement. Just based on the number of unpaired electron, calculate the magnetic movement, but directly it is not possible to calculate the magnetic movement. Okay, so this is the limitation of VB theory. So the next theory is the crystal field theory, CFT theory. So in CFT theory, we expect the coordination compound. What is the color? Is the main point. And another one, talk about the magnetic movement. Can you understand, children? So in CFT theory, talk about the color of the coordination compound and magnetic properties. Okay, so here take the two complexes. One is octahedral complexes and another one tetrahedral complexes. Okay, so using that is two complexes, explain the magnetic properties and explain the color. Okay, and another properties also. Okay, so in crystal field theory, talk about the color. Okay, so next one, magnetic movement. This is the aim for CFT, magnetic movement. Okay, so here have some rules and regulation in CFT theory. In octahedral, so what is the rules? How the electron it is filled. In tetrahedral complex, how the electron it is filled. Okay, here have some rules and regulations. And another one, in CFT theory, assume coordination compound, you know very well. For example, COF6. Okay, this is the coordination compound, metal and ligand present within the coordination sphere. Next, this one, overall charges. Okay, metal positive charge, ligand negative charge. So positive charge, negative charge has some attraction, electrostatic force of attraction takes place here. Okay, so here between metal as well as ligand, the bond is 100% ionic bond. Okay, in CFT, strongly give the data about the bond is nearly 100% as the ionic bond. Here positive charge, here negative charge. So now between COF, okay, here 6F. So here the bond is this bond is ionic in nature. This is one of the assumption of CFT theory. Okay. Now talk about the octahedral complex. Okay. In octahedral complex, distribution of electrons in d orbitals. Now study the crystal field theory in octahedral complex. Okay, octahedral complex means, you know, the number of ligand is 6. Okay, tetrahedral ligand means the number of ligand is 4. That's all. Okay, you know very well. So see the example, COF6, CO cobalt metal, F fluoride ligand, negative type of ligand, metal positive charge, fluoride ion negative charge. Okay. So in CO, now here to form the complexes, metal ligand to form the coordination complexes. Okay. This concept is explained in the CFT theory. Okay, how the complex is formed is explained based on CFT theory. This is the aim for the CFT theory. Okay, children. Okay, so in CO, cobalt is the D block element. D block element means the outer valence electron is present in the d orbitals. Okay, so d orbitals means it contains 5 orientation. Okay, d orbitals. Now write the electronic configuration. Argon. Okay, 18, 4s 2, 20. Cobalt atomic number 27. So here 3d7. Okay, so now here 3d orbital 7. So now this d orbital mentioned here. Are you clear, children? Okay, so next to find out the oxidation state, it is variation. For example, here cobalt X, fluorine -6 equal to -3. So X is equal to +6 -3. So +3 oxidation state. So CO +3. +3 means what is the electronic configuration? 3d6. Are you clear? Okay, so in 3d6 electron in metal. Okay, so now fluorine 6 fluoride ion, it combined with or it approaches to the metal and to form the coordination compound. Okay, so this concept is explained in based on CFT theory. This is the general concept. Okay, children. So now d orbital, 5d orbital. Okay, 5d orbitals. Write the representation dxy. dy is it, dx is it, and dx square minus y square, and this one dz square. You know very well. Okay, so here also you know the concept already studying. That is the shape of orbital, s orbital, p orbital, d orbital. This first 3 has same pattern. The second 3 has same pattern. Same pattern mean here, for example, d. Okay, x, y. So now to consider x axis, y axis. Here z axis. So now the lobes. This one we pronounce as lobes. This point. Okay. So now it present between the axis for dxy, dyz and dxz. Okay. In dx square minus y square as well as dz square, the lobes are present. This one x axis, y axis. Okay. Present along the axis. Here between the axis, here along the axis. Same for dz square. Now this one to consider z axis. So z axis, the lobes are present. Next, electron cloud at the center. So here the lobes are present along the axis. Here this 3 d y z. This one y axis and z axis. So now the lobes are present between the axis, and dx z, x axis, z axis, lobes between the axis. Are you clear, children? So dxy, dyz, dxz. The lobes are between the axis. Okay. So now the ligand fluorine. Just to take the example here. Okay, consider. So fluoride ion approaches the metal. Okay, so whenever it approaches the metal, here electrons. Here how many electrons? 6 electrons. Here also how many electrons? 6 electrons. So repulsion takes place, not attraction. Okay, here electron, fluoride ion also electron repulsion. So due to this electron repulsion, now this degenerate d orbital. Degenerate means 1, 2, 3, 4, 5. This 5 orbitals are same energy level, no variations. Okay, so now this 5 degenerate 5d orbital has same energy. Okay, so now here due to repulsion, now this energy level it move to the excited state. Okay, energy level increases. So now draw the 5d orbitals. Now this degenerate d orbital, it rise the energy. Okay, why the energy level is raised mean due to the repulsion. Okay, so now just to consider here center metal, it is present here. Okay, so 3 axis, x axis, so here write plus x, this opposite side minus x, next y, here minus y, this one for z, so here minus z. Okay, now this structure is denoted as the metal. Okay, so metal has denoted the axis plus as well as minus, so totally 6. Okay, so now ligand is approaches to the metal. Okay, now ligand 1, ligand 2 and ligand 3, ligand 4, ligand 5, ligand 6. Okay, 6 ligand. So the 6 ligand approaches the metal. What happens? Now to form the repulsion. Okay, and next one to form the spherical field. So energy level is variation. Okay, so degenerate same energy level is not degenerate. Average energy of d orbital in spherical crystal field. Now you know the meaning about spherical. Okay children, here metal 3 axis. Now ligand approaches to the metal. Now repulsion takes place at the same time to form the spherical field. Okay, so here writing the word spherical crystal field. Okay, so now the energy is excited. Energy level increases. Okay, so in d orbital, non-degenerate d orbital, now the ligand approaches. So here whenever the ligand approaches to the 5d orbital, now here repulsion takes place. Okay, so here more repulsion in dx square minus y square as well as dz square than dxy, dyz and dxz. Why mean here the lobes are present along the axis. Here the lobes are between the axis. This is the reason. Okay, so now splitting of energy level takes place. Okay, so here splitting is started due to the repulsion. Okay, so here which one is the high energy among this 5? This 2 also high energy. Okay, so here T2, this one dx square minus y square and this one for dz square, high energy level compared to this. Okay, so here totally 5. So 2 it present the higher energy level and 3 are present in lower energy level. That is denoted as repulsion is less. Here repulsion is more. Okay, so here dxy, dyz and dxz. So now the energy of 5d orbital is split. Okay, so this term is known as CFSE, crystal field topic, splitting energy. Okay, the symbol representation is delta. Now study the topic in octahedral complex. So write O. Okay, children. And next one, this dxy and dyz and dz square, it denoted the letter as T2G. Easily you can remember 1, 2, 3. So 1, 2, 3. Okay, term T2G. At the same time here, two orbitals. Okay, so here use the word as EG. EG orbital, T2G orbital and EG orbitals. Okay, so here the energy constant. So this one is denoted as energy barrier. Okay, energy barrier. Okay, so now find out how much energy. Okay, this is center part, energy barrier, constant one. Okay, so next the remaining part, how much that is energy. So overall how many orbitals? 5 orbitals. Okay, so denominator write 5 orbitals. Okay, so here energy is increased, here energy is decreased. So how much energy is increased? 2 part compared to this. So write 2. Okay, so next one, here write the symbol delta, crystal field splitting energy, and O. This O denoted as octahedral complex. Okay, so same way for, so energy difference is 2 by 5 delta 0. And next this part, energy is overall 5 orbitals. In 5 orbital how much it is increased? 3. Okay, so here write 3. Okay, children, so here increases, so put the positive symbol. Here energy level decreases, so -2. Are you clear? Okay, so now the topic is crystal field theory. In crystal field theory, talk about the formation of coordination compound. So here ligand approaches to the metal. In what ways it approaches? Studied in this topic. Okay, so first one, d orbital, 5d orbital, all are same energy level. So we are using the word degenerate, 5d orbital. So now repulsion, due to repulsion the energy level is increases. Okay, so in the degenerate, non-degenerate orbital, our average energy of d orbital. Now to start splitting the orbitals, it is split into 3 and 2. Okay, in octahedral, EG is present at the higher energy level and T2G is present at the lower energy level. So this splitting is known as crystal field splitting energy, and delta is the symbol for crystal field splitting energy. This O is denoted as octahedral complexes. Okay, so next afterwards ligand, again that is approaches. Now just we are representing the metal only. One metal electron alone we are displaying here. So now ligand approaches to the metal. Okay, so now energy level decreases and to form the complex formation. Are you clear, children? Okay, so now study the next part in tetrahedral complex. Crystal field theory is explained how the electron are distributed. Okay, children, now talk about the next concept, crystal field splitting in tetrahedral complexes. So tetrahedral complex example, the coordination number is 4. Okay, any example, for example Ni, NH3, Ni nickel metal, ligand NH3 4 times 4. Okay, so it is a tetrahedral complexes. Okay, children, so now in according to crystal field, how the electron distributions we studied here. Okay, but in both also octahedral as well as tetrahedral, both also similar, but only one variation. After the crystal field splitting, EG and T2G, the position variation. Okay, it was only slight difference alone. Okay, so in tetrahedral complex as usual metal. So metal means d orbitals. Okay, so in d orbital 5 orientation, 5d orbital it is present. Okay, so here degenerate orbital all are same energy. Okay, same energy level. This one is represented as dxy. dx is it, dy is it, dx square minus y square and dz square. Okay, all the 5d orbital has same energy. Okay, so now as usual, now this d orbital is coming from the metal. Okay, so now this ligand approaches the metal. Ligand has electrons. So now repulsion takes place, spherical field repulsion. Okay, so now this degenerate orbital, the energy level is increases. Okay, increased energy level 1, 2, 3, 4, 5. Okay, so this one for non-degenerate orbital or average, okay, d orbitals in spherical field. So in this energy is constant. So now here splitting takes place. Okay, so it is split into 2. Okay, so here in octahedral Eg is more repulsion. Okay, so Eg is more repulsion means in Eg orbital means these 2 lobes present along the axis. Okay, but here the lobes are present between the axis. So here now the electron that is reaches the metal in dx square minus y square as well as dz square, high repulsion. Okay, in octahedral, but in tetrahedral more repulsion in d2g. Okay, so here dxy, dx is it, dy is it. So more repulsion takes place. Okay, so here more repulsive force takes place. So more repulsive force means the energy level increases. Okay, so here write dxy. dx is it, dy is it. This one is energy state. It is called as T2g. Okay, but in tetrahedral we never use the word G, only D2. Okay, so in lower energy level dx square minus y square dz square. Okay, here Eg, but here don't write the letters G, only write E. Okay, so here the center energy barrier. Okay, so here the whole term is known as crystal field splitting energy or crystal field stabilization energy. Okay, the symbol is delta. Now study the topic tetrahedral. So write the symbol delta T. Okay, so this T denoted as tetrahedral complexes. Okay, so now find the energy difference. Okay, between dx square minus y square dz square to energy constant, and next remaining part. Okay, so here overall how many orbitals? 5 orbitals. Okay, so how many it is increased? 3. Okay, so same way for here the overall 5. Okay, so how many it decreases? 2. Okay, so here energy level decreases, so minus. Here energy level increases, so put the positive symbol. Okay children, so now study the topic crystal field splitting in tetrahedral. So now I explaining along with the structural explanation also. Okay, so now in tetrahedral complex, center metal is d orbital. So all the 5 d orbital same energy. So we use the word degenerate orbital. So this degenerate orbital, now ligand approach to the metal, now repulsion takes place. So energy level increases. Okay, so now here splitting takes place in the non-degenerate orbital. So it is split into T2 as well as E. Okay, so here delta T, delta denoted as crystal field stabilization energy or splitting energy, T denoted as tetrahedral. So here also write delta T and here also write delta T. Children, we assume the tetrahedral complex is assumed in the cubic structure. Okay, metal it present at the center. Okay, so here only 4 ligand. This 4 ligand is approaches, okay, to the diagonal way to reach the metal. Okay, ligand approaches to the metal through this diagonal path. Okay, so now here 5d orbitals. Okay, so in among this 5d orbital, see here x-axis, y and z. Okay, so this one for diagonal part. So here one ligand, here another one ligand, same way for top, alternative one. Okay, so here one ligand, here one ligand. So now talk about the repulsion, this 5d orbitals. Okay, so in 5d orbital, this dxy, dxz, dyz, the lobes are present between the axes. Okay, so more repulsion takes place than dx square minus y square and dz square. So more repulsion means the energy level is high. Okay, so again this one explained based on this cubical representation. Okay, so once again, so now see the tetrahedral complex. Okay children, now till the complex is not formed, just we representing only the metal part only, just distribution. Okay, so now start ligand approaches to the metal. Okay, so ligand negative, metal positive, so attraction takes place. So now less attraction, so now to form at the same time the energy level also it is very less. Okay, so now to form the complex compound. Are you clear children? This is the basic. Okay, so till I never explained the color and the magnetic movement. This color and magnetic movement topic we discuss mean this is the basic concept in crystal field theory. Okay, so crystal field theory main aim is discuss the coordination compound, such and such colors and magnetic movement. This is the two aim. Okay, so this crystal field theory explain two concepts. One is octahedral complex and another one is tetrahedral complex. Even in octahedral and tetrahedral, this diagrammatic representation only variation for here, but remaining everything is same. In octahedral, Eg is present at the higher energy level and D2G present at the lower energy level. And another one, children, keep in your mind, in tetrahedral complex, don't say the word T2G. G want to remove, okay, only T2, only E. Children, now I explain the theory, okay, now apply the example, okay, how to fill the electrons in the non-degenerate orbitals. Okay, so see the example, CO F6 3 minus, CO metal, F ligand. Okay, so cobalt, first find out the oxidation state. Cobalt oxidation state consider as X, fluorine minus 6 equal to minus 3, so X equal to plus 3. Okay, cobalt atomic number 27. Okay, so now in cobalt plus 3 electronic configuration, this already you know very well, so I write directly here 3D. Okay, 3D7 4s2, 3D7 4s2 for cobalt. In cobalt 3 plus 3 electron it is last, so 2 plus 1 3 electron is last, so remaining 3D6. Okay, So now this one octahedral complex. So now to apply in the crystal field. Okay. So d orbital 1, 2, 3, 4, 5. Here 6 electrons. Okay. So 1, 2, 3, 4, 5, 6 electron. Now in the presence of ligand, now splitting takes place. You know the rules. Okay. So here increasing energy is increased due to repulsion. So now splitting takes place. Okay, splitting takes place. This one for octahedral. So octahedral means here write that high energy is Eg orbital, low energy is T2G. Okay, so now here the same energy, now splitting takes place. When the splitting takes place? When the ligand approach to the metal. Okay, so now splitting takes place. Here total number of electrons 6. So now at the same time here this fluorine is the weak ligand. Okay, so now later on I explain strong ligand and weak ligand, how to identify. Okay, so now fluoride ion is the weak ligand. So now this 6 electrons now to fill in this crystal field. So 1, 2, 3, okay, 4, 5 and 6. Here the splitting is very less. Okay, so then the crystal field stabilization energy is very less. Are you clear, children? Okay, so from this, now to fill this electron. Okay, so from this we can further details also we can collect it from here. Here the electrons are unpaired, not pairing. So unpaired means we can say it is a paramagnetic in nature. Okay, so next one, this one to identify the low spin as well as high spin complexes. Okay, before that I write another one example, CO. Okay, NH3 6. Here 3 plus. Okay, children. So here NH3 is a strong ligand, but at the same time it is a neutral also. So now cobalt oxidation state +3. Okay, electronic configuration 3d6. Okay, so it's similar to that. So 5 d orbital. Okay, energy excited. Here also non-degenerate orbital. Okay, 5. Now splitting takes place. So here this one for octahedral. So no changes. Here Eg. Okay, here T2G. But here the condition, this splitting takes place is more. Okay, so now this energy is very large compared to this. Okay, compared to this energy is very big. Okay, very high. Okay, so here Eg, here T2G. T2G. Okay, now to fill the electron, here 1, 2 and 3. Okay, so now here the energy difference is very high. Okay, so now again now electron filling here mean it takes larger amount of energy. So fill the electron here itself. So pairing. Okay, here pairing takes place. Pairing. Remaining 3 electron is filled. So pairing. So pairing it required less amount of energy. Pairing. Okay, but here delta G, delta crystal field splitting energy in octahedral complex energy is more. Are you clear, children? Okay, I hope you can understand very clearly. Now I take the 2 examples, COF6 and CONH36, weak ligand. So splitting energy is very less. Strong ligand, so more repulsion. So energy level is high. Okay, so now here 3 electron is filled. Now 4th electron is filling here means high energy. Comparing high energy, maybe if fill the electron here means it needs less amount of energy. Okay, so which one is Preferred more means this alone is preferred more. Okay. So here pairing energy. Okay, as well as delta 0. Okay, here delta 0 lesser compared to the pairing energy. Okay, so now here electrons are pairing, so it is a diamagnetic in nature. This one for paramagnetic in nature. Okay, so next one, further the electron fill in the Eg orbitals. Okay, so inner orbital. Further electron from the ligand adding electron in Eg orbital. So this one for inner orbital. So inner orbital means you know very well, that is denoted as low spin complexes. Okay, low spin complex. Here the electron is added. Okay, here also. Okay, at the same time adding the electron here also. So this one is denoted as high spin complexes. High spin complexes. Okay, this one low spin, high spin complexes and outer orbital. Are we clear, children? Okay, so in the CFT theory, we can possible to discuss the compound is whether it is a paramagnetic or diamagnetic, and low spin or high spin, or inner orbital or outer orbital. We can take that data using the crystal field theory. Okay, children, because now within this video I can explain this example and you can catch the point. Okay, it is very useful for you. Okay, so at the same time, now using the CFT theory, the compound is colored. Okay, so how it is possible? Now I give one example and I explain. The example is, so now the example is TiH2O 6 times. Okay, here plus 3. Okay, so this one D block titanium, atomic number 22. Okay, argon 3D2 4S2. Okay, so now to find out the oxidation state, water, neutral ligand. So titanium plus 3, titanium plus 3. So plus 3 means 3D1. Now to apply the crystal field. Okay, now splitting takes place. Here always in octahedral, number 6 octahedral. So Eg higher energy level, T2G lower energy level. Okay, T2G, Eg. Here non-degenerate. Non-degenerate 5d orbital. Okay, in the presence of ligand, it is splitting takes place. Okay, here the electron is only one electron. Okay, so now it's a ground state. So this one electron is easily excited to Eg. Okay, so from this we can understand here DD transition takes place. Okay, so due to DD transition, the compound is colored. Are you clear, children? CFT is the main concept. Explain the compound is colored or not. Explain the colored. Okay, due to based on DD transition. DD transition. Here D orbital. This also D, this also D. Now the electron is transferred. Okay, lower to higher. Again higher to lower. So now the light energy is emitted in the form of radiation. So now color is produced. Okay. So now in VB theory, why colored substance it is not possible to explain. In VB theory, this 5d orbital. Okay. Right, in the same energy level, only one electron present. Maybe this electron is shifted, go to the next level means just present here only. So no energy variation. Okay, children. So this is the main reason in VB theory cannot explain the colored substance. But in crystal field theory, mainly splitting, based on splitting, now to explain the substance is colored due to DD transition. I hope children you can understand this session. Thank you.